This is another one of our functions questions. So essentially what we're doing in this one is, first off we have to find the domain and range of this function. We have 1 over the square root of 3x minus 6. Now, just a couple of rules to be aware of. Now, the key one in particular in this case is the radicand, which is this part of a square root term, must be greater than or equal to 0, okay? And also we sort of assume that the output of a square root function, it must be positive, okay? So that's the first thing we have to consider. The 1 over the square root of 3x, the square root of 3x minus 6 is greater than or equal to 0. We're not going to be finished there, but we're just going to sort of start off with that, okay? So the radicand must be greater than or equal to 0. So 3x minus 6 must be greater than or equal to 0, okay? So x minus 2, divide both sides by 3. 0 divided by 3 is 0. Okay. X minus 2 is greater than or equal to 0. So x must be greater than or equal to 2. Okay. Now, so that's the first part. The x must be greater than or equal to 2. So that's the first consideration. Now, the second consideration is that we have a fraction here. Okay. And so the numerator is 1. Now the numerator can take the value 0, but we can't let the denominator, that's an N there, N-O-M, denominator equal to 0. So the denominator cannot equal to 0. So essentially, just as a sort of quick remark, the square root of 0 is equal to 0, okay? So essentially what we can't, this radicand part, for this particular question, because it's a fraction, now this is not general to radicands, it's just because it's the denominator also, this square root term. This cannot be equal to 0, because if we had, for example, 3x minus 6, square root of 3x minus 6, and this turned out to be the square root of 0, we would have 1 divided by 0, which we can't have. We can't divide by 0. So essentially, for the denominator to be 0, x must be equal to 2. Okay, I'll just give you a quick example there. So f of 2 equals 1 over the square root of 3 times 2 minus 2. That is 1 over 0. Not allowed. Okay. So in this case, we have to sort of go back here to this expression here, and we can't no longer can have it greater than or equal to 2. It can only be greater than 2. X must be greater than 2. Okay, 2.01, that'll be fine. Okay. So anyway, our domain is 2, actually, sorry, square bracket, no, round bracket, to infinity. Okay. The square bracket means we can include 2. The round bracket means anything greater than 2, but not 2, okay? So 2.001 is fine, but 2 is not okay. Now, the range of that function here, okay? Well, essentially we can have 1 over the square root of, so essentially, like, we can just disregard the stuff about radicands and so on. The numerator is 1, it's a positive number. The square root function will always give us a positive number. Okay, that's just the sort of convention that we're using in this course. That the square root is the output of a root function is considered to be positive. For example, square root of 4 is considered to be 2. Okay, so the essentially we have a positive number over a positive number. We cannot get an outcome of 0 there. Okay. Because the numerator is essentially for a fraction to we can't get a negative number. Okay, first off, we can get any positive number, but can we get 0? No. Okay, the only way we can get we can't get a 0 outcome here. If we have a fraction, the only way a fraction can be 0 if a over b is 0. Okay, that's the numerator and denominator. The only way this will work is that a has to be 0. Okay, so in this case, the numerator 1 is not 0, so we can't get an outcome of 0. So we can get any positive number we can't get a negative number, and we can't have 0. So anyway, the range is 0 to infinity. And again, we can't have 0 there. So 0, the round bracket means anything greater than 0, but not 0. Okay, so the next part of this problem is f of x equals 1 over the square root of 3x minus 6. Essentially what we have to do is evaluate f for, this is a composite function problem essentially, f for 3x squared plus 2. So essentially what we're going to do here is write out f of x, okay, and where we have x, we're going to replace it with 3x squared plus 2. Okay, so essentially what we've done there is f of x, okay, so essentially we have 3x squared plus 2, just put it in there like that, okay, where the x would normally go. Okay, so let's do that. So what do we have? We have 1 over the square root of 3 times 3x squared is 9x squared. 3 times 2 is 6, so plus 6 minus 6. Okay, and so the plus 6 and minus 6 cancel out. So what do we have? We have 1 over the square root of 9x squared. So essentially the square root of 9x squared is 3x, so we have 1 over 3x. Okay, and again we're assuming the positive root always. Okay, so that's part A of this question, so I'm going to move on to part B now.